Can you tell me a little bit about Switch? Because I saw a fantastic building, but what is happening inside there?
Yeah, so Switch is one of the largest data center operator in North America. Our campuses are 100% renewable energy, and each facility is multi-gigawatts. And to give you a kind of a bit of a context, state of California uses about 28 to 30 gigawatt, including Hollywood and the Silicon Valley. So these are highly scalable power systems that we operate. We're also a founder-led company. Rob Roy is a technology innovator. And if you look at in our industry, the hot aisle containment concepts, designs, these are all initial Switch designs that were created by Rob. And yeah, it's a pretty exciting time in our industry to be in this place. So.
But you're in a space where there are many companies like you. So how do you differentiate?
Yeah, I think, let me tell you my own experience. As you see there, my personal time when I walked into one of the Switch facilities and get to experience them, you know, I've been driving car all my life, and then you got to see a Bugatti for the first time. It sinks on you. It's like, oh, what does a scalable power system looks like? How the power distribution and cooling works in conjunction with the environment that it operates. And how do you build a sustainable data center? These are different class of problems that not every one of us get to experience. How does the facility design, construction, and the whole logistics of it that you need to put in place? And then how do you operate that with the highest level of uptime over years? So.
Yeah, because like a bank, as we just saw, you know, it is a very, very business-critical environment, right?
Absolutely.
So you can't afford any downtime. So the choices you make are super critical in every part of the architecture, I can imagine.
Absolutely, absolutely.
So what have been your biggest challenges there?
Yeah, our industry, and I think we all as a society is going through a very interesting time. We're at an inflection point where it's not the capital, but it's the availability of the power that is the primary constraint for digital innovation. And that's a very important point. We haven't experienced that before.
So you got to optimize, I'm sure, to make sure that you don't waste it.
Yeah, and just for everybody to relate to it and get some perspective of it, like an American household consumes about 2 kilowatt of electricity. An IT rack, let's say running Rancher on it, consume about 5 to 7 kilowatts. NVIDIA H100 racks consume about 35 kilowatts. And the NVIDIA's GB200 racks consume about 135 kilowatts. So you can see this is not a linear growth. It's an exponential growth in the power consumption we're experiencing. And it has quite a lot of interesting, complex problems for us to tackle. As I said, right, that providing power reliably is one part. How do you cool down that infrastructure? So think about the heat capacity of air. It becomes inefficient around 35 to 40 kilowatts. So now when you look at a GB200 rack, you got to bring liquid to it. You got to bring direct-to-chip cooling to it. What does that mean is that I have to go hire biochemist and CFD, computational fluid dynamic person, to build a reliable and scalable infrastructure to bring massive volume of water close to these highly expensive gear. And they need to operate at scale with 100% uptime. So that's amazing set of technical problems.
That's a massive challenge in an infrastructure space.
And I think there's one more point that I want to highlight that for this audience, when we do workload scheduling, in any cloud-native environment, like let's just say you're writing a scheduler for Rancher Prime or any harvester and all of that, we always had 3 dimensions that we make trade-offs or allocation or orchestration decisions around, which is storage, compute, and networking. And the assumption was the power is a facilities problem, right? It's just always there. But when you look at any AI cluster of a reasonable scale that we operate, one run of a job could easily be a 10 megawatt. 10 megawatts, just again, 2 kilowatt per household. Imagine from a grid perspective, how many households, how many cities are you talking about when you run a workload to just run a training algorithm? So what we come to see that power is no longer a utility. It's a dynamic resource that needs to incorporate with your workload scheduling at that scale. So to point of like, I think, why am I here at SUSECON? Now think about that. This is a very complex set of problems across the stack. We can see that the growth is not linear, and the problems we have to solve are not very well understood, both from physics point of view, from facility point of view, from operational point of view. So we have to really think about it from a software as a systems perspective. Now, you have to think about how we build our software, how we operate our software, and how do we scale that software. And that's where cloud-native principles come into play. Whether we're writing a control software, whether we're writing a monitoring, or whether we're doing a CFD analysis, we run it on top of cloud-native systems like Rancher Prime.
Oh, that's great. So this is like super complex, and I'm not sure about the audience, but for me, there's a lot of new stuff I learned here, because infrastructure is not just that simple, right? If you see the complexity. But in all of this, you chose to work with SUSE. Can you explain a little bit what your experience has been with the people in SUSE that you worked with?
Oh, brilliant. I mean, I like working with nerds, so... I've been a fan of OpenSUSE for a long time. I've been modifying SUSE Linux, quite some time. So it's natural for me on a personal level. But I think there are a few things that were strategically important for us to partner with SUSE. One was we wanted to have a partner whose philosophy aligns with us. Not all open source is the same. And as I said, it's not just about how I run the compute stack. I need to also think about how we run our control software. How does the edge Linux distribution, what are my choices in the market in terms of having a mutable kernel with a very minimal user space that I can run mission-critical control systems on? And then the most, I would say, underappreciated part is that all of these facilities are part of critical infrastructure. Software supply chain is absolutely critical for us, that we have trust and auditability in how a software from a very foundational level comes into our systems and operate these facilities. So SUSE has been a critical decision for us, and absolutely fantastic to work with.
That's really, really great. Well, I'm very, very glad that we are able to allow you to use all these great open source technologies, but in a business-critical environment with all the support that you need from the SUSE nerds and everybody else in SUSE, and that it's going so well. We love the partnership, and I'd like to thank you so much for joining us on stage today.